Hi, it's Ms. Quisenberry, and we are going to be talking about lessons 3.1 and 3.2, where we learned about using arrays to model multiplication and using arrays to identify factors up to 30. So, what we did first is we pretended these cubes were chairs and that there were 12 of them. And then we arranged these in different ways to show those 12. So this is 12 cubes, and I'm going to arrange them like it was an audience watching a play or in a movie theater. And we want to have them equal. Each row has to be equal, each column has to be equal, but none left over. So there's no friends that are left alone. Everyone has someone by them. So now we have all of these in rows and columns. And rows go across. So this is a row. And columns go, erase that, columns go vertically. So this is a column. So now I want to look at it and I want to say how many rows and how many columns. So it looks like we have 1, 2, 3 rows. So we have 3 rows. And how many columns? 1, 2, 3, 4. 4 columns. Now, is there another way to do this? There definitely is. So I made a mistake when I was recording, and I moved these around, and I moved it. So now I have 4, 1, 2, 3, 4 rows. Let me write that down. And how many columns do I have? 1, 2, 3. 3 columns. Do you notice anything about this? Last time I had 3 rows and 4 columns, and now I have 4 rows and 3 columns. They're just switched. Are there other ways I could arrange these? There definitely is. So can I move these? What if I try 2 rows? Maybe I can move them so they're all in 2 rows. So I've got my 2 rows and I'm just moving these over to these craziness. Now, look, I have 2 rows. They each have 1, 2, 3, 4, 5, 6 in them. So I have 2 rows, 1, 2, 2 rows, and 1, 2, 3, 4, 5, 6 columns. Could I arrange them another way? Woo! Definitely. I definitely can. What if I just move these guys down here, like this? Now I have 1, 2, 3, 4, 5, 6 rows and 2 columns, which is just reverse of what I had last time. Now there's one more way that I could arrange, well, actually 2 more ways that I could arrange these, and I'm just going to show you what they are. So now I took these 12 cubes and I have them in 1 row, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. I can just move these, which I don't think I'll have space, but I could take it and I could now change it so that I have 12 rows and just 1 column as well. Now imagine that we had 16 chairs. We could do the same thing. So if we move these around, we want to have them in equal rows and equal columns. And I don't want any little friends left over. We're here watching the movie and everyone has to sit in their row and column. Just like at the movie theater, you can't just like take your chair and sit off in nowhere by yourself. You have to stay in the rows. And these friends don't want to line up. So now I finished arranging them, and I have 1, 2, 3, 4 rows, and I have 1, 2, 3, 4 columns. Are there any other ways I could do this? Definitely. What if I try this? Now I have 3 columns, but oh look, there's a friend left over. That's not going to work. So what if I take this third one and I try making it into just 2 columns? Now look, there are no friends left over. Everyone has a spot. And we've got 1, 2, 3, 4, 5, 6, 7, 8 columns. And we have 2 rows. Oh, that was wrong. We have 8 rows and 2 columns. That means if I have 8 rows and 2 columns, what else could I have? It's almost like I turn it. I could have 2 rows and 8 columns. And again, I could make 1 row or 1 column and have all 16 in there. So what kind of shapes did these make when I was making this? What kind of shape does this kind of look like? Yeah, it looks like a rectangle, a quadrilateral, or at first it looked like a square. The 4 rows and 4 columns look like a square. But those are a type of quadrilateral and a type of rectangle. So it's making a rectangle. Did it matter if I had 12 or 16? Which one were we able to make more different arrangements with? Let's see, we made this one, we made the 4 rows, 4 columns. We made 8 rows, 2 columns. We made 2 rows, 8 columns. And we can make 1 row, 16 columns, 16 rows, 1 column. We actually were able to make more with this one because last time we did, oh no, we made more with the other one because we did 3 rows, 4 columns, and then flipped it, 4 rows, 3 columns, that's 2. Then we did 2 rows, 6 columns, 6 rows, 2 columns, that's 4. And then we did the 1 and the row, 12 columns, and 12 rows, 1 column. So with the 12, we were able actually to make more, even though 16 is a bigger number. That's interesting. So now we're going to be making, what we were arranging those into were arrays. I forgot to say that when we were doing rows and columns. So now we see we have an array card here in front of us, and we see one side has lines and one side is blank. So we're going to label these with the multiplication expression that goes with it, and that just comes straight from the rows and columns. So I have 2 rows, 1, 2, so I'm going to write 2, and I have how many columns? 1, 2, 3, 4, 5. So I'm going to write 2 times 5. And then I'm going to do the columns first. 1, 2, 3, 4, 5 times 1, 2. So then on the back, I'm just going to put how many rows there are, 2. And in the middle, I'm going to put how many squares there are total. Now I could count these, 1, 2, 3, but I want to think about some other strategies I could use. Since I know there's 5 here and 5 here, I could do 5 plus 5, and that would be 10. Or since I know each column has 2 in it, I could count by 2s. 2, 4, 6, 8, 10. So I'm going to put 10 in the middle. Then we put our initials in the bottom corner, which I don't need to do that. So now let's take a look at another array card. Now this is just the front. So we're going to look at the rows. 1, 2, 3, 4. So I would write 4 times, and then and how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'd write 4 times 9. And what else could I write? I could do the columns first. So I do 1, 2, 3, 4, 5, 6, 7, 8, 9. I wanted to count it again to make sure I was right. Times. And there were 4 rows. So that would be the front. Now this would be the back, but there's no back on here, so I'm just going to write it over here. So on the side, we would write a 4 on the back. Ooh, I should have written it not with my mouse. And then we put in the middle the how many total squares there are, which is the product. Now, 4 times 9, that sounds pretty challenging. I don't know how to count by 4s. I'm not sure how to count by 9s. But could I split it in half? And then I would just have 2 rows of 9. So I could do 9 plus 9, and that'd be 18. And then I would just have 2 18s. Or I could count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18. And then I'd put those 2 18s together. And then, so 10 plus 10 is 20. And 8 plus 8 is 16. 20 plus 10 is 30. So I get 36. So I'd write in the middle on the back 36. Maybe I should write that here. What happens if I were to turn this card? Would it matter? Would these be the same? Could I write these same multiplication expressions? Yeah, I could write 9 times 4 and 4 times 9 again because I have 9 rows and 4 columns. So the order doesn't change the fact that there are still 36 squares here, even if I turn the card. I wonder if I can rotate it. I don't think I can rotate it yet, but it doesn't change. So that is what we worked on in lessons 3.1 and 3.2. Thanks. Hope you have a great evening or afternoon or day. Bye.